Hello guys, this is module 3b and we will try to understand our Ohm's law. Now look here, when it comes to the Ohm's law, we might have seen this Ohm's law definition at so many places, but what we need to understand over here, that in a given circuit, the potential difference across the end of the conductor is directly proportional to the electric current flowing through it. So if I have to simply say what exactly the Ohm's law is basically a relation between the voltage and current. But there is very important point which you need to remember, that when he has derived this relation of voltage and current, he has considered one particular thing constant, which is temperature. So when I say that according to Ohm's law, my voltage is directly proportional to current, but you people should always remember that Ohm's has considered the temperature constant. Now what is going to be happen over here, we simply know that whenever we have a proportionality sign and if we remove it, we have to introduce some constant. So the constant which I'm going to introduce over here is R, and this R is something which is known as resistance. We have already seen that how the resistance depends on various factors. So you have one more formula to calculate your resistance. If I make R as a subject, it will look like V over I. Now what you need to remember, that this constant over here is R and that R is known as resistance. Now if we need to understand few more things regarding the resistance, what do you need to understand? Let's say resistance is nothing, it is simply the opposition in the flow of electric current. So when I take my wire, you already know that these are the atoms which are present in a wire, and there are electrons which can be red dot which are free from these atoms, and they will flow whenever there is an electric potential difference between the two ends of the wire. Now definitely here the resistance depends on what? Resistance depends on the number of atoms. So if you have any particular material in which the number of atom is high, that means your resistance is also going to be high. And that is the same reason, if these two things are high, that means the amount of current which will flow through the wire is going to be less. So that is what is indicated by this over here down. If I take some other material and if I see the number of atoms in that particular wire is low, my resistance will also be low, and in that case my current is going to be higher. So if I have to choose like what exactly this means, definitely material A, here you have higher resistance, so the application can be based on heating effect. So I will prefer to use this material when it comes to the heater, or even if I have to make a geyser, I will definitely use this wire inside the devices, the instrument. When it comes to this particular material over here, I have a very less resistance over here, so these particular wires or materials can be used as the connecting wires, because this connecting wire role is simply to conduct the flow of electron from one point to the other. There is no such thing. The better it will be, the less the resistance will be present in these connecting wires. So this is something which we can conclude from here, and we already know that the SI unit of resistance is ohm. Now if we go ahead, we have to understand that what do you mean by resistance in series and resistance in parallel, because in electric current you will always find there are only two types of connection. Any complicated circuit can be a combination of these two, but there is always two connection which we need to know. One is series, one is parallel. So how exactly a series connection look like? You can see it over here. We have a battery, we have a plug, and we have connected three resistance, and when the current value flows in this particular wire, the current has to go through R1 first, and the end of R1 is connected to R2, and the end of R2 is connected to R3. Such type of connection are called in series. Now if I have to understand this particular example over here, that how exactly the total resistance can be calculated, which we call it as equivalent resistance, what we can understand, we know that current always going to be flow from positive to negative terminal. But if I give you an example, let's say initially there are 6 electrons which started their journey from the battery, and the battery was having some certain voltage, let's say it is 20 volt. Now 20 volt, or you can say 20 joules per coulomb. As I already told you that volt can be written as joules per coulomb. That means every single electron is having 20 joules of energy behind them. They started moving in this particular path. they come across R3 over here. So what they have done, definitely R3 is a resistance, means R3 is going to be consume some energy over here. So these electron, which are the 6 electron present over here, initially they have 20 joules of energy with them, but the moment they cross R3, the R3 has consumed some energy, which I can write it as 10 joules per coulomb R3 has consumed. Or you can say joules per coulomb is nothing, it is volt. So let's say 10 volt has been consumed at R3. Now definitely all the electron will pass through R3, because your electron number, make sure at the negative terminal these electrons are going to be reached. Whatever the number of electrons are coming out of the negative terminal, they have to reach terminal which is positive, because this is the law of conservation of charge. A charge cannot disappear in between the circuit. So all 6 electrons will come to the positive terminal. Now at this point, definitely number of electrons are 6, but now the energy which they have, as they have already consumed 10 joules of energy per coulomb, or you can say per charge, so now they have remaining energy, which is again 10 joules per coulomb, because 20 minus 10 is going to give you 10. R2 consumes some amount of energy, so once they cross R2, they have spent some 7 joules per coulomb, which can be written as 7 volt. Now what is the energy with this? Definitely 10 consumed in R3, 7 consumed in R2. Now the remaining amount of energy is going to be consumed by R1. So if you wanted to write it as 3 joules per coulomb, or I hope you now understood that we can directly write it as 3 volt, and then electrons are going to be come out over here, and now they have no energy, they will simply go to the positive terminal. The important thing which you people need to notice over here is what? Through every single resistance, how many electrons are passed through? 6. And definitely your value of current depends on what? Flow of charge. So what I can say over here, that when the resistance are in series, my voltage is going to get divided, but as the number of electron passing through every single resistance is same, my current is going to be remain same for R1, R2 and R3. Now if I simply conclude this particular part over here, what I can say, that my formula which is given by Ohm's law is V is equal to IR, but I can understand one thing, that my voltage value for R1, R2, R3 is going to be different, because R1, R2, R3 value is also not same. If it is same, then let me tell you the voltage consumed by them will also be same. But here R1 is high, R2 is moderate, and let's say R3 is very less. So in that case the voltage value is going to be different. So what we can say over here, that if I have to calculate, like in the previous case you have seen the battery which I have taken is 20 volt, and the voltage was getting as 10, 7 and 3, which simply says that if I add all my potential difference in the wire across the resistance, I'm going to get as my total voltage. So I will simply start this expression by saying that my source voltage, which is over here, I will get it if I simply add my V1, V2, V3 values. But I know that V1, how do we write it as? V1 we can write it as IR1, because let me tell you, in this circuit the current which we have, it is going to be remain same throughout the circuit. So the only value which we need to take care of is R1, R2, R3. So V1 can be written as IR1, V2 can be written as IR2, V3 can be written as IR3. And when I'm going to plug this value of V1, V2, V3 over here, my expression will look like this. And if I have to calculate my resistance in series, or let's say my equivalent resistance, the I value can be cancelled on both the side. The resistance in series will simply look like R1 plus R2 plus R3. So this is how we actually calculate whenever there is a question based on resistance in series. We will simply add up the resistance values. Now when we take an example of resistance in parallel, this is how the circuit will look like. Now you can say that over here, that your positive terminal which we have, it is connected to R1, it is connected to R2, it is connected to R3. So even if one of the appliance over here is not working, make sure the circuit will be complete. But this was not the case when the resistors are connected in series. If any of the appliance is not working, the rest of the appliances are not going to work as well. So in parallel, as you have seen, that every single resistance is getting a connection supply directly from the battery. I will take the same example, that 6 electrons started their journey, and when they reach at this point, now they have a choice. They have 3 different routes available for them. R1 is the one which is having a maximum resistance, only 1 electron prefer to pass through it. R2 is moderate, so let's say there are 2 electrons which will be able to pass through it, and R3 is the minimum, so maximum number of electrons are decided, let's go through R3. Now before they actually enter, every single electron, whatever the voltage you have over here, let's say 20 volts, mean this energy behind the electron is going to remain 20 joules per coulomb, 20 joules per coulomb, which I am writing as 20 volt, 20 joules per coulomb. So what we need to understand over here, all the electron, the energy which is driving them, the energy which is behind them, it is same for all of them. So what we understand from here, we understand that here in this case my value of current is going to be different, because from R1 you just have a single electron passing through, and the flow of current depends on flow of electron. So this is my I1, and here the value of current, let's say it is going to be I2, and here the value of current is, let's say it is going to be I3. But if this is what the current will appear to be, what we need to understand, so my current value is going to be get divided in the circuit, but let me tell you, my voltage for all 3 is going to be remain same. So this is the best part. So resistance series and resistance parallel, whenever we have to do this expression, we always have to take care of which part, that which physical quantity is going to get divided. So here in this case, I will simply say that if I have to find the total current, I will simply add up my I1, I2 and I3. If I have to write the value of I can make I as a subject, it will look like V over R. But I1 if I write, I have to write it as V over R. But in this case, make sure voltage is going to be remain same. So the value of R will be written as R1. So I1 is V over R1, I2 is V over R2, I3 is V over R3. Let's plug these values in this particular equation. We will simply observe that the voltage on left hand side and the right hand side is going to be get cancelled. So resistance in parallel, how do we write that? 1 by Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In most of the cases, you will find that we have 2 resistance connected. So the formula can be written as 1 upon R1 plus 1 upon R2. But I would suggest in such cases, you should always be familiar with one formula. Like if I solve this, because people usually forget that this is 1 by Rp. In the end, you have to take Rp at the numerator. So you have to flip it. So if I simply remember one thing, if I take the LCM, it can be written as R1 into R2. This will be R2 over here. This is R1. I need to calculate my resistance in parallel. So I will flip this. So 1 by Rp, if I flip it, here it will also be R1 and R2, which will come at the numerator. And this is, instead of writing R2 plus R1, I am writing it as R1 plus R2. I want you people to remember this formula whenever it comes to the resistance in parallel, and you just have 2 resistance given in a circuit. So what we will do, we will simply say if I have to calculate my resistance parallel, I will take a product of 2 resistance at the numerator, and I will take addition of 2 resistance at the denominator, and I will get my value directly. How it is, that I will show you. Now if we have to calculate here the equivalent resistance in a circuit, I told you resistance, we have only 2 types, series and parallel. So this circuit, if you actually see, let me tell you, this can be a combination of both. So some value of resistance has been given to you. What we need to do, the simple strategy, if you see such complicated circuit, you do one thing, you just redraw it again. Why? Because no matter what, I can see one particular thing over here, that these 3 resistance which we have over here, they are going to be in series, because whatever current enters over here, it is going to be remain same for Q to R, R to S and S to T. So I will simply add these three resistance, and instead of making the whole diagram with these three resistance, I will simply say that after solving this QRST part, the value which I will get is 2 plus 2 plus 2, which is going to be 6 ohm. Correct? Now one more thing. Now if you look at these two resistance, they appears to be in parallel. So what we will do, again we will redraw this circuit, we will simplify it, and we have seen when the two resistance are in parallel, we have a formula that resistance parallel can be calculated by R1 into R2 upon R1 plus R2. So this will look like 6 into 6, which is 36. 6 plus 6 is going to be 12, and this is going to be 3 ohm, because 36 divided by 12 is 3 ohm. So I will do one thing, that instead of drawing the circuit again, the complete circuit again, I will redraw it, and I will simply mention that if you solve this QT part, beyond QT the total resistance is going to be 3 ohm. So this is what my answer will look like. Now what we can suggest, again I can see PQ TU, this part again look like in series. So again if I redraw my circuit, I will see that 5 ohm is actually present over here between P and U, and this part 3 plus 1 plus 1 is going to give me 5 ohm. Now I don't think I have to again redraw it. I simply conclude, like in this circuit which was looking a bit complicated in the beginning, if I simplify my diagram, my final resistance appears to be two resistance connected in parallel, and these resistance value is 5 ohm each. So I will say my resistance equivalent is R1 into R2. So I will say 5 into 5, and this is 5 plus 5, 10. So which is 25 divided by 10, going to be 2.5 ohm is my R equivalent. So I'm not writing RS or RP, because RS stand for resistance series, RP stand for R parallel. But here we are calculating the combination of resistance which we have in the circuit. The final answer is going to be 2.5 ohm. So this is how you people can solve complicated circuit by a simple technique which we call it as redrawing technique.